And hello again, year 4D. Today we're going to look again at finding factors and factor pairs. If you remember from yesterday's lesson, a factor is a number that divides into a larger number. So one of the factors of 25 would be the number 5, because 5 divides in, well, 25 is divisible by 5. A factor pair of 25 would be 1 and 25. They multiplied together to make 25. Another factor pair of 25 would be 5 and 5. 5 times 5 is 25. A factor pair for 10 would be 1 and 10 and 2 and 5. Okay, if you need any recap on factors, go back to the video from yesterday. Anyway, today we're looking at what factor pairs can we see with these arrays. So an array, as you know, is aligned a series of dots that shows a multiplication. So this shows 16 altogether. So I can see that the factor pair for the moment for this 16 is 2 by 8. So that's the factor pair here. So this one shows 2 times 8 equals 16. Now I wonder if I can rearrange these to make any different ones for 16. Because I know that there are going to be there's more than one factor pair for 16. Now, yesterday I said that there's always a golden rule. You can always do number 1 by the entire number. So in this case, the entire number is 16. So that's another factor pair. 1 times 16 is 16. Now let's think. What other numbers divide exactly into 16? There's only one other set of numbers, only one other factor that can go in. All the numbers have to be less than 16. 15 doesn't do it, 13 doesn't do it, 12, no. We've got 2 times 8. To 5 go in? Let me count up. 5, 10, 15, no, 5 doesn't go in. So I'll try 4s. 4, 8, 12, 16. Good. So how many lots of 4 is that? Let's just check. So I'll get 4 of these. 1, 2, 3, 4. Oh, let's not rotate them, let's move them. Okay, and I'll get another 4. Excellent. Another 4. And lastly, another 4. So now I've got a new array, which is 1, 2, 3, 4 by 1, 2, 3, 4. So my final factor pair for 16 is 4 times 4. 4 multiplied by 4, and that is 16. Fantastic. And that relates to this question on your challenge sheets. So again, you just need to do one section of this because it's exactly the same on both sides. So this one is, what factor pairs for 12 do these arrays show? So you just write down what the factor pairs are shown by the arrays there. Nice and easy to start with. Then we look at factor rainbows. Now, don't be confused by all the lines and stuff because these are actually quite easy. You find in all the different factors for 10 and matching them up together. So, like we know, 1 and 10 are going to be your two first easy factors to guess. So 1 and 10. What other numbers multiply to make 10? 3 times 4, no, that's 12. 1 times 9, no, that's just 9. 2 times 5, yeah, 2 times 5 makes 10. So I'm going to put a 2 in this box, and I'll put a 5 in this box, and I'm going to finish my rainbow by using a nice line here. I'll give it a bit of colour as well, and there we go. Factor rainbow for 10. Nice and easy. Now I'll look at the next page, 18. This is a bit tricky, and I've got 4 boxes here, which means there must be 2 extra factor pairs. I've got 1 and 18, all done. So I'm going to start doing some multiplications in my head to check which ones are which. So 1 and 18, yep. What multiplies together to make 18? 4 times 6? No, 4 times 6 is 24. I feel like I'm close with that. Oh, 2 times 6. No, that's 12. 2 times 5 is 10. Oh, I've got it. I've got it. The other one, or one of the other ones, is going to be, let me just write it to the side here. it's going to be 3 times 6, because that equals 18. So 3 and 6 are my other factor pair here. I'm not going to put them in just yet though. And I've got another one. I think I'm going to try and find half of 18, so I'm going to divide half of 18. No, I'm just going to divide 18 and find half of it. So 18 divided by 2 is, let's count up in 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 9. You can't see my fingers, but I'm holding up 9. So 2 times 9 equals, oh, not 19, 18. Right, so to finish this factor rainbow, I'm going to put these in the right places. Now I want them to be in order, which is why I put them over here to start with. So first I'll do 1, and I'm going to put the 2 in this one. So 2 goes here. And I want my rainbow to match up, so I'm going to make sure that my lines are going to the right places. So I'll just have a nice yellow line coming from here. And it's going to go all the way over there to the corresponding to the opposite side. And I'm pretty sure you can guess what I'm going to put in there. It's going to be, I hope you guessed it, it's 9. And then the last one is going to be obviously a 3 and a 6. Good. Alright, and I'll put my little blue line going here. Nope, no, I won't. I'll get the line first. Then I'll get my blue line and I'll finish off this factor rainbow. Lovely. It's a nice easy way to find factors. Off we go. So we go to our document and it just says complete these factor rainbows. This one is for 28, so you can do that. So 4 times something is 28, 14 times something is 28, and 1 times something is 28. And the other one is for 16. Then it's asking you to draw your own factor rainbow, so do one for 20, do one for 48. And then you come down to the challenges. Okay, so have a quick look at these. There's 3 of them. So, odd one out, circle the number which does not have 6 as a factor, then explain your choice. My tip for you to do this one would be to count up in your 6's and to see which one is not there, but you're going to have to explain your choice for me there anyway. Ella the Egyptian says, the bigger the number, the more factor pairs it will have. Do you agree with Ella? Explain why or why not. You're going to have to look at some big numbers and find out how many factor pairs they have. Okay, and that'll give you some of the answers to that one. My computer's just crashed a little bit. So have to wait for it. Off we go. And this last one here, reasoning and problem solving, true or false. An even number always has an even number of factor pairs, and an odd number always has an odd number of factor pairs. Is this true or false? Prove it. So what you'll have to do is find even numbers and find all the factor pairs of them. So you might write the number 28 is even. Find all the factor pairs of 28. Are they all even numbers? Or is there an even number of factor pairs? Find an odd number, for example 27. Do they have an odd number of factor pairs? True or false? Prove it. Okay, well, enjoy your maths, kids. Speak to you soon.